Hey everybody, today we have a digital projection EVision WUXGA 6800. This particular projector was sent in because it has some weird warning error lights on it, and need to figure out why and where that is coming from. So let's check the lamps, make sure they're connected right, and then we'll go ahead and fire it up and see what it's doing. And this is a dual lamp setup. Takes two NP21 LPs. I think this might be based off of an NEC at one point. Let's see. This one definitely ran hot. You can see the stickers very discolored. That's a problem. But the bare lamp looks okay, wires look okay. Nothing sticks out here that scares me. So let's put that back in and snug these down. Now the other lamp assembly I know has a stripped out fastener on one side. They told me about that. I'm gonna see if I can fix that. I'm gonna try and do a helicoil or something, but the thing that fastener usually goes into is missing. They sent the fastener separately. And this one looks alright too, same thing, still shiny inside, wires look alright. It looks like this one was changed at a different point than the other one because it's a different series. But they look alright, so at least enough for testing. I don't know if they're bad, but we should be okay with that down, that down, that down. There we go. I just want to see if it has any error lights or anything. So let me get you guys looking at that. Power on. Alright, we have standby. Let's see, anything else? Goes to orange, that's normal. So we want to see if we get any flashing warning or flashing lamp lights. So green, good. Went right, 2, 3, 4, 5, 6, 7, and then solid. See, I don't hear any of the fans coming on. Definitely didn't hear the color wheel spin up. And there's something making like a slow fan noise, just like, it's hard to describe. It's just inside. Let's see if these change at all. Let it sit for a moment and see what happens. And I know all the filters are snug. It's none of that. I think we might have a power supply problem. Well, either way, we're going to have to take the top off. So, went back to standby. And solid red on lamp 1 and 2. That means lamp circuit failure. Yeah. So most likely we've got a power supply issue. Let me realign you guys and we'll start taking it apart. First thing to remove, besides the power cord, is the lamp door. And then we have 1, 2, 3, 4, 5 screws here. 1, 2, 3, 4, and 5. Get those out. And then there's a whole bunch in the bottom. And these are long. So all the screws in the bottom are going to be long like this one. Let's see, that should be everything. Yep, that's all the ones on the bottom. Got that. Is there one in here? Nope. It's a lens lock. There's no screw in there. Alright, let's take the top off. Alright, disconnect the keyboard wire that plugs in right here. Let's set that over here. Here's the insides. So this thing is well built. It looks like we have to get, I think, into here, if I remember correctly. I worked on a Ike, I don't know, something that had this similar frame in it, and I remembered the power supply being up in the front, and looking at it, going by the thermal switches here, and this is going to be our mains into the power supply, so I'll bet you our issues in here. Now, but first, let's get that metal frame off the top. Okay. To get in here, we need to disconnect a bunch of wires. Disconnect the mains. Down here, this is ballast control right there. It's those two. This wire, that's a lamp output. So this is a ballast output right here. And it looks like, no, got another. Mains maybe, PFC, temperature sensor, not sure now. I guess we'll see when we get inside, but let's get all that disconnected out. Here's another lamp output wire down here. Alright, let's get the top. Let's get the top off. Okay, here's our power supply. Let's see if we can get this whole thing out, this whole can. I just want to get that power supply out. Alright, I think I figured it out. There's a pair of screws on either side going to a bracket. I think that will get us free. Alright, so the low voltage is going out down here. That's that wire. We'll see what we can do there. Yeah, there we go, see? Alright, let's see here. Oh, pardon me. Alright, let's see if we can, what we can get loose here. Where'd that other screw go? I dropped a screw, it's still in there. There we go. Let's see, so this is PFC out right there. That's feeding our ballasts over on that side. So I got a pair of ballasts in here. That's power to them. Here's our low voltage out right there. So this power supply, this is what we need to check out. Alright, so let's just kind of, let's give it a visual first. You know, look. Let's see, we got a fuse here for the PFC, and we got a fuse here and a fuse here. A couple fuses. We got a relay. No bloated caps. That's good. Everything else seems to be. Oh, we got another fuse here. All right, let's get this out of the frame, and we will get the meter on it and see what we got going on. And if I don't see anything obvious, I'll figure out how to hot wire it out of circuit. Let's see, PFC out, AC in, low voltage out. All right. Alright, let's check some fuses. Let's see, that's here to, that's good. Here to here, yeah. That one. Yep. And this one. Okay, fuses are good. That's weird. I mean, that's good, but also kind of Makes things a little more difficult. I was hoping we'd find a bad fuse just by the way it was acting. Let's see. Oh, that's good. Alright, so let me see if we can figure out how to hotwire this so I can check it. I think if I can just get power in on red and black here, I'll be in good shape. So maybe I'll just solder something on there. So I soldered on a plug so we can, I'll use this extension cord. It's hooked up to a dim bulb tester. Let's check this diode. Let's see if we have any voltage, any residual voltage. A little bit. Alright, that's good. $115. Let's see, here's our bridge. That's weird. Got nothing. Alright, let me put some gloves on. Got it plugged in. Let's see. So you guys can see that. Alright. So let's see, ground. Do I have 3.4? I do. 3.2 rather. No 12. So I got 3.4 or 3.2, but I got no 12. Interesting. So I have no 12 volts in that power supply. So I have plugged in just a switch to the PFC control. Heard that relay kick on. Let's see if we have power factor. 392. I like that. Let's see if we have 12 volts. We have 12 volts. Do we still have 3.2? Still have 3.2. So let's turn it off. Heard that relay click off. We lost the 12. We still have the 3.2. Alright, so the 12 doesn't come on until it has mains power. So this power supply seems okay. That's weird. I wonder if we should check the ballast. I wonder if the maybe there's a problem in there. Maybe we'll pull one out. We'll check one ballast. Okay, so I pulled that main board out of the projector. There's definitely something up with it. I desoldered a bunch of these little surface mount caps because I noticed when going from ground to positive, you guys should be able to see the meter. Turn the beep off. So here's ground. So it should be, you know, about 0 ohms. Then if I go to the positive side, I'm getting about 40 ohms. And I was getting that across those. And then on the other side, down here, there we are, where I marked them 1, 2, 3. I initially found it here by going to these coils, and I'm getting about 40 ohms to ground from these inductors, and I'm pretty sure these are part of a power supply. So again, I thought maybe one of these caps are shorted. They're not. I'm still getting 40 ohms. So I started checking all the diodes going around. You know, they're good. Because I figure one of these diodes is going to be on the output of the whatever buck or boost converter is going on here. I came to this one. I think, is it a coil? Yeah, see, that's an inductor. It looks like a diode, but that's an inductor. That's good. So the diodes are all checking out. So I'm trying to find where this positive is coming from, and what I'm worried about is that it's in this Valens chip VS100RX. I haven't looked that up to see what it is. I am hoping it's something to do with the network, because it does seem like it's got stuff going that way. And over here to that control, I'm assuming it's some kind of FPGA or something, because it does have a crystal. I hope that maybe I could take that out. If I remove that chip, it'll remove the short. But I'm just trying to find out where the source of the positive is that goes to these. You know, we get 27 ohms one way and 36 ohms the other way. So there's like a 10 ohm difference. So if I go on the positive side and then we go to the power input, that's ground, ground. So it's not, doesn't look like it's coming from one of the main power supply pins. Definitely has to be a secondary power supply, and that would explain why the projector tries to turn on, why it has some function. So the trick is really got to find where that positive is coming from. Let's go to the board. This connector here goes down to the fan control board. I don't know what the technical name for that board is, but it's the one where all the fans plug in. Mechanical board, maybe. So let's see if any of that. Let's go across these two caps and see if we get 373. So that's probably going through a diode. Yeah, so that's across a diode. So those caps, I was really hoping we just had a bad ceramic cap. So we're looking for 0 ohms, not 27 or 36 or 37. There's ground, ground. Let's see, any of these DVI connections maybe? does not go to the DVI. It does go to this very tiny capacitor here. One of these, wait, let me find it. Is it this one? Yeah, so that one, I can't really see where it goes. This must be an EEPROM. What's under here? Yeah, see, it's got to go somewhere. Let's go to this coil. No. Okay, so this Valens chip is actually a receiver. It's a VS100RX receive. It's connected to the RJ45 so that it can process video that's being sent to it through the network. So that's feeding into an HDMI port somewhere, or channel on probably this chip, I'm guessing. So I want to see if we have any connection between here and those problem areas. Okay, so yep, you guys can see that. So let's go to the positive side. Alright, nothing. I didn't think so. It's worth a shot. Yeah, so that's the output of that. So they have these in parallel. That's what it seems like. Let's get a good connection. Looks like these are in parallel. Yeah. So whatever's driving these goes to those capacitors. I don't know if that's an RC network, but I'm pretty sure it's part of power control. Either way, I'm 99% positive having resistance like this across where a capacitor should be is wrong. Let's check these two guys too, make sure they're not. Nope. Nope. Looks good. Yeah, I really think the problem is coming from that Valens chip. I'm going to go up to the PMD 1000 power control. Yeah, nothing up there yet either. Oop, wait a minute. Alright, I'm going to go look at this in the microscope, and if I see anything interesting I will take some stills and show them to you. Alright, so I did a little more research and checking, and I found that the positive sides and those inductors go to this chip right here, and that's a TPS 54610. It's a power control IC. That's how it is on the board. PH is what they call phase output. If you want to pause it and take a look at that stuff right there, you can get an idea what the pins do. So power comes in right here, ground, control nonsense, and then output, and that's connected to the internal MOSFETs. So I verified that it indeed, I've got my probes twisted here. So if we go in any of the pins, 14 all the way down to pin 6, so we'll just 13 and 14. Oops. And we have direct continuity there. So that tells me that this chip is definitely feeding it. Now physically, there's no holes, chip's nice and flat, but it does connect to there, and I'll bet if we go from ground, which is pins 15 to 19, and we go across, I'll bet we find that resistance. 28 ohms, 37 ohms. Now, is it that chip, or is it what that chip is powering? I don't know. But that's what we're going to find out. Let's desolder that power pack chip. I hope this setup is good so you guys can actually see what I'm doing here. This isn't how I usually work on boards, but I figure for the video it'll make it easier for people to see what I'm doing. So let's get the hot air. I should be able to just desolder this without any low temp solder. Let's just get my tweezers on there. Now I'm hoping it's this chip because these are available. It wouldn't be too hard to replace. I think we'd be in good shape. I worry that if it's that other chip, that receiver, if that's bad, I kind of think that might have some kind of firmware on it that I can't program. Now it may use those eepoms behind it, but I'm not sure. But it would kind of make sense for this chip to go bad. It is a power chip. It probably gets hot. It would be a reasonable failure point in my opinion. This board's really thick, so it takes a lot of heat. They're starting to go, though. I can see them starting to change colors. I just don't know if it's glued underneath. I know sometimes they glue these. Oh, now it's coming. I just saw a pin wiggle. There we go. Okay, so it did have a heatsink pad underneath, so that makes sense why it was such a pain to get off. Alright, let's set iron back down. And let's check this chip. How do I want to do this? I need to make sure the back is insulated. Okay, so I just have this chip sitting on top of this backside of a lamp timer board. It's all insulated there because it has the solder mask. Just want to see if from those same pins, if from the output to the ground, if we get that low resistance. Let's see. No. Wow. So this chip might be okay. Ew. Yeah, I think that chip might be alright. Alright, let's set that out of the way. Let's get our main board back. And let's see if we still have the same thing or if it's changed. 11 ohms because it's hot. See if I cool it off, will it go up? Yep. So as it warms up, the resistance is rising. Here, let's cool it down. Let's cool everything down. And that was just some rubbing alcohol. That should have cooled it down. 16 ohms, oh boy. So it is changing temperature, or changing resistance with the temperature. That's weird. I know the solution would be a new main board, and I am going to look into that, but I would rather not go that direction if we can help it. Alright, so it is coming back up. Let's try something. I am going to point the heat gun right at the chip, and we're going to watch the resistance. Let me go the higher direction. I'm starting to think that Valen's chip is bad. So chip. Alright, let's see if we can take this off. This is not going to be easy, I don't think. I don't have my bigger nozzle on here, but you know what? I've done it before. Let's see if I can do it again. I'll bet you right now it's a dead short. I wonder if maybe there's a solder blob underneath that's causing this. Yeah, look at that, 1 ohm. Yeah. It's this thing. As soon as I start hitting the heat on it, even if I go on the components next to it, it doesn't change like that. So it's this Valens chip. Now what I need to find out, because there's no data sheet, I need to know if this is programmed. I kind of don't think it is. I think it's probably using those eepoms. It's using a ROM. But what I'm sort of hoping, I'm going to check with the customer, if they don't use the LAN, then we might be able to just take this chip out and just not use it, and they just don't have any LAN control. And that might not matter. I might have to do this tomorrow. Bring my larger tip in. I usually don't have to do stuff this big. Usually it's just little things, so I don't keep a big tip here. I could also try heating it from underneath. It's starting. I heard click click. That's the solder joint starting to melt. almost got it. There we go. That actually came up really well. And then I'll use this to cool it off. I just set it on this block of aluminum and that'll heat sink it away. I do see some sketchy looking joints all over the place. The center didn't look too good. I can see the color difference, see the shades. Well, don't, stuff closest to us, don't worry about that. But here, this thing got hot. Chip got hot and cooled itself down again. Alright, now let's see if that short is still there. If that short's still there, weird. Ready? Fingers crossed. 1, 2, 3, check. Hey, look at that. Wide open. That's what we want to see. That's entirely what we want to see. So let's put those capacitors back on. I'm going to use my new mini soldering iron, my, oh wait a minute, there we are, NF Mini. In fact, I want you guys to see that again. I love this thing. NF Mini, I got this from Northridge Fix. I got all 3 tips with it, the whole 9 yards. Absolutely love it. Fantastic. It's got a good Type-C power supply. It's just very, very comfortable to use. Heats right up. All right. Oops, wait a minute. Actually, let me get in there and clean that up a little. Alright, let's see how this goes. Well, solder tweezers would work way better here. I gotta get myself a set of those. Dang it. I am really surprised that chip went bad. They must have gotten a surge through the land, maybe? Wonder what would damage that. Any ideas? Or maybe you work for digital projection and have seen this happen before? And if you have, stick it down in the comments. Alright, that's good. Okay. So we'll just go across. Yeah. Alright, and in fact, I want to clean up. They're not as straight as I would like them to be. I'm just going to heat these up together so that they all drop down into position. Turn the temp down a little bit. There we go. Just wanted to flatten them out a little. Alright, one more time. Let's go across these caps. Should be very high resistance. Yeah, I like that. Yep. So that's the problem. A Valens chip receiver. Did find these on eBay in China for 15 bucks plus shipping, so maybe. But what we're going to try first is I'm going to put this back in without that chip. See what happens. I mean, it's, you know, it didn't work. It's not like it's going to didn't work more, so we'll be back. Okay, so now before we put this board back in, the one where I removed that chip, we are going to, we got to put the iris motor back together. I thought the iris motor may have been part of the issue, but it definitely does not seem to be part of the problem. So we're going to put these screws back in that hold that board in place. Let's get the, pardon me, let's get this plastic ready. Throwing screws on the floor. And my good screwdriver, where is that? It's over here. Alright, so let's see, so it's gonna be, it's gonna go like this. Wait a minute. There we go, this way. Alright, I like that. 1, 2, 3, so it's going to go like that, and we'll have to resolder the actuator back in place. But let's put the one screw in that will hold this, and then I'll get my NF Mini soldering iron and we will reattach that flat flex cable. That'll go back around to those two contacts, and then I'll put the plate back on and we'll drop it on back in after we redo that. So let's get the NF Mini. Love this thing. Absolutely love this thing. If you need a micro soldering iron, I can't recommend this any higher. It's I have an older Weller pen iron, and mini pen iron, and it's nowhere near as nice as this. I don't know who actually makes this, and I'm sure Northridge Fix had input on designing it, but whoever builds these, they very good build quality. And I like how you just touch that little button and it wakes it up, and then it heats right up. There's one side. Oh, lift it up too quick for the solder. Let's try it from this side. I just got to hold it down so that I don't burn myself, but so it's lined up. Dang it, come on. Alright, there's one side. Trying to see how I can do this without burning myself. Need some flux. Hang on. There we go. Had to get some fresh solder on there. See, something's got to hold that down. Find a clip. Let's put some fresh solder on the positive, and then use these tweezers. There we go. So we're going to try that main board without that chip. I don't know if it needs it. I'm hoping it doesn't, but we will find out. See, do we get okay? So it is waking up. See, we got that guy flashing down there, and that's over there. It is now officially in standby. Let's hit power and see what happens. Nothing. Still dead. Oh, I forgot to plug the ballast in. Okay, that was intentional. I was testing you guys to make sure you noticed I didn't plug the two ballast wires in. Now these are the lamp switches, but we soldered those over so that we don't have to have them plugged in. So let's try it again. Nah, nothing. This isn't good. I think it's done. It may need that chip. Yeah, unfortunately, we need a main board. So, although, let me get my meter. Let's see what kind of voltages we have on that main board. Alright, so we should have, if this chip is working, unless it took out that chip too, which I guess is possible. Let's see, the input is, let's get our, alright, so VN is the 6th pin over, 20, 21, 22, so somewhere here, 3.2 in, volt out. Still got 3.2. One, two, three. No power good. Oh no, there it is. We have power good. But we're only getting 1 volt out. That's weird. Doesn't feel like it's getting hot. Yeah, okay. So output voltage is 0.9. That's right, that's what we're getting, 0.9. So that chip's working. 0.9. Alright, so let's check on the ballast control then. Six, eight. Yeah, this thing's cooked. Well, unfortunately it needs a main board. I don't know where I'm going to find one. So, this might be the end of the video here. If we don't see something after this, then we'll call it. I think I might get the scope though and just give it one more once over. It's just weird that that chip failed. I don't know why it would have failed. So anyway, so I got to find a main board for one. DP7656 2973088 704. Maybe those are the part numbers.